have 51 ends on a square, and what we know is that the edge of the square has length 1, okay? So the area of the square is 1 times 1, 1. Fine. And we have these 51 ends displaced over this square. Then you know that you have a glass that has a radius of 1 divided by 7. The question is there a way to take your glass, put that on a square, and be able to capture, or if you don't want to use capture, to say to, I don't know, encompass or to cover 3 ends. Now, also here, there are different possible solutions. In particular, you can imagine that the thing that we have to do here is to decide how to somehow tessellate, how to split the square into smaller areas, okay? And there you have an infinity of possibilities. You can divide into smaller squares, into circles, into triangles, you choose. So here there are many possibilities. I will just consider the simplest one. That is to say, to split the big square into smaller squares. But why is it important? Because every time you have a question of this type, that is to say, you have a certain number of elements that you have to put in a certain number of boxes, holes, areas, geometric figures, and then you want to know if every single element, every single box, every single hole, every single figure contains at least a certain number of the initial objects you were considering. This is what falls under the name of the pigeon principle. It's called the pigeon principle because it was initially developed using pigeons as the objects that need to be displaced. So the idea is the following. There are 2 versions of this principle. One is the basic one, and one is the generalized. Typically, you need the generalized. So you have a certain number of holes, okay, or boxes, let's say n, and then you have a number of pigeons which is larger than n. So let's say is more than n plus 1. We are speaking about integer quantities, okay? So you cannot have half a pigeon. So if it's larger than n, it's n plus 1, n plus 2, n plus 3, and so on. So if you have n holes and more than n plus 1 pigeons, then, and this is a trivial result from an intuitive point of view, there will be holes with more than 2 pigeons, okay? Depending on how many pigeons you have. So this is the basic result. Now, this result can be extended in the generalized pigeon principle. And the generalized pigeon principle states the following. I have n holes and at least n times m plus 1 pigeons. If this is the case, then at least n plus 1 pigeons will be in the same hole. So I will have a hole that contains n plus 1 pigeons. Now, why is this useful for our problem? Because if you remember, or if now you know the pigeon principle, you immediately have a very simple way of solving the exercise, which is the following. So is there a way to transform the data that we have here, 51 ends, into a combination of n and m? Actually, it is, because what we are looking for is 3 ends, okay? And for us, 3 ends is the n plus 1 term that you see here. So 3 ends for us corresponds to n plus 1 pigeons. So if I have n plus 1 pigeons, and for me the n plus 1 is equal to 3, it means that m is equal to 2, okay? And if m is equal to 2, and I'm considering n times m plus 1 pigeons, I immediately also have n, because now I have that n times 2 plus 1 is equal to the number of n's, or the number of pigeons. So if m is equal to 2, and I have that n times 2 plus 1 is equal to 51, trivially n needs to be 25. So, and in fact, this is what I can do. I can split my big square, not so big, okay, it's size 1. So this square into 25 smaller areas. Why 25? Because I want to satisfy the requirements of the generalized pigeon principle. So since m plus 1 for me is 3, automatically I have m equal to 2. And if I have m to 2 equal to 2, n times m plus 1 is equal to 51, m is equal to 2, n needs to be 25. Okay? So I have to split my square into 25 areas. If I split the square into 25 areas, then the pigeon principle tells me that in one of these squares, in one of these areas, there will be 3 ends. Now, I already told you squares, because the simplest way in which you can split a square into smaller areas is to split the square into squares. So if I take squares that have an edge of 1/5, I can completely cover my big square with 25 non-overlapping smaller squares of edge 1/5. And in one of these squares with side length 1/5, so 0.2, the pigeon principle tells me that I can expect 3 ends. Now the question is, okay, if I split my area into 25 smaller areas, in one of these I will have 3 ends. The question is, can I capture those 3 ends if I use my glass? And here is just a very basic geometrical question. Now, if I have a square that has an L side length of 1/5, so 0.2, the area of the square will be 0.04, okay? Now the question is, what is the area covered by the circle that represents the glass? In that sense, I know what is the radius. The problem told me that the radius is 1/7. So I take what? Pi times 1/7 squared. If you compute that, the result you get is 0.064, and 0.064 is larger than the area of the square, which is 0.04. So since the area covered by the glass is larger than the area of the small square that contains 3 ends, the answer is that yes, with this glass I can actually find a way of covering and capturing 3 ends over this square that contains 51 ends.